afternoon. Today we are going to discuss about the topic half adder. So there are two types of circuit in digital system. One is combination logic circuit (CLC) and sequential logic circuit (SLC). In combination logic circuit, it depends only on the present input. In sequential logic circuit, the output depends not only on the present input but also the past output. So in combination logic circuit, the example is arithmetic circuit, code converters. In sequential logic circuit (SLC), the examples are counters and shift registers. So we are moving to see in detail about CLC, combination logic circuit. Consider this as a CLC. We are providing n number of inputs with m number of output. CLC or combination logic circuit contains an input variable, output variable and a logic gate. The logic gates used in the CLC are NAND gate, NOR gate, NOT gate, etc. So next we are going to classify the CLC. The combination logic circuit is mainly divided into three: arithmetic and the logical function, and data transmission, code converters, in arithmetic and logic system there are adders, subtractors, comparators. Are under the arithmetic and logic function. Multiplexers, demultiplexers, encodes, and decodes under the data transmissions. BCD, binary, 7 segment are under code converters. So we are discussing about the half adder. This is under arithmetic and logic function. So this is for an introduction of half adder. So half adder, adder is a logic circuit which uses binary additions are called the adders. The basic operations of adders we know that is A and B, if A is equal to 0, B is equal to 0, the output of sum is equal to 0. If A is equal to 1 and B is equal to 0, the sum is equal to 1. If A is equal to 0, B is equal to 1, sum is 1. If A is equal to 1, B is equal to 1 and sum is equal to 0. Here sum is equal to 0 and there is a carry 1. This is the basic operation of adders. So there are different types of adders: half adder, full adder, parallel adder and serial adder. So today now we are going to discuss about half adder. So the definition of half adder. Half adder is a foundational combination circuit in digital electronics that adds two single bit binary numbers A and B. It produces two outputs, sum using XOR gate and carry using AND gate. I repeat again. Half adder is a foundational combinational circuit in digital electronics that adds two single bit binary A and B, it produces two outputs, sum using XOR gate and carry using AND gate. So in simple terms we can say that half-adder is a logic circuit that adds single bit binary number. It's a single bit binary number and there are we get two outputs. One is sum and other is carry. So the truth table of half-adder. Here we can add one more column, carry. So if the variable input A and B, two input 0 and 0, our sum is 0 and our carry is also 0. If the input A 1 and B equal to 0, our sum is 1 but our carry is 0. And input 0 1 input 0 and 1, sum is 1 and carry is 0. And in the last column, input 1, output 2 input 1 1, sum is 0 and carry is 1. Here only the carry is become 1. So next we want to write the key map for sum and carry. So we want to write it separately, the key map for sum separately and carry separately. First we want to write the K-map for sum. So what is K-map? K-map is a graphical tool used to simplify Boolean algebraic expressions and minimize the logic circuit without complex arithmetic theorem. So that is K-map. So we want to draw the K-map for sum. Mark the sum which gives us 1, which equal to the sum equal to 1 we want to mark here. So first is A is equal to 1 and B is equal to 0. This is A is equal to 1 and B here is 0 and here A is second column A is equal to 0. A is equal to 0 and B is equal to 1. This is the K-map for sum. Here grouping is not possible. So we want to take them as symbol. So we are writing the expression in SOP format, that is sum of product. SOP is sum of product. So S is equal to A. Here first column A is equal to 1, first row A is equal to 1, B is equal to 0. Therefore B dash plus second row A is equal to 0, B is equal to 1. Therefore A, B dash plus A dash B. This is the SOP format of K-map of sum. So A B dash plus A dash B is equal to A XOR B gate. So we can write A B dash plus A dash B is equal to A XOR gate. This is equal to A XOR gate. We can write A XOR is equal to A XOR B. So the features of XOR gate is if two inputs are same, output is 0. If two inputs are different, the output is 1. So the XOR gate is like that. This is XOR gate. So next we want to write the K-map for carry. K-map for carry. The same thing, when the carry is equal to 1, we want to mark in the K-map. So in the first is equal to A1 and B1. So AB, C is equal to AB is our expression from the K-map because A and B are 1. So this is the expression for K-map for carry. So A and B is the logical diagram and gate. The logic diagram of AND gate is used here for representing carry. So next we want to write the block diagram for half adder. So the block diagram is our input A and B. We get sum and carry. Sum is A XOR B and carry is C is equal to AB. So now we can draw the realization diagram using logic gates of half adder. So the diagram is, first we want to draw the XOR gate. Next we want to connect the AND gate here. This is XOR gate and this is AND gate. This is for A XOR B sum and this is for output carry AB AND gate.